So part C of this problem
That's actually pretty cool. I like that.
says to determine the speed. It's waiting for you to look. Here we go.
Is it cold?
Oh my god, it is.
Oh, we'll put that in the bloopers.
But you can't see it. We'll only see the
Yeah, you can only see the board. You can't see me. Alright,
Thank
here we go.
You okay, Molly?
No, I'm hungry.
Morgan, what are you not hungry?
Can I make you a sandwich?
Yes. Yes, please.
Did you see how fast he said yes?
Please. Sandwich. Actually, do you have buffalo turkey?
I have turkey, but not buffalo turkey.
Can we get
Let's see.
I-
Do you have peanut butter and jelly?
You can get a sandwich when I'm done with this project.
Oh,
You can get a sandwich. You can get a sandwich right now. Don't worry.
No.
I give you permission.
Okay. So part C of the board, you guys shut up.
Oh,
Shut up, punk.
Oh,
Yeah.
You know I'm gonna go eat your food. I've had enough of this. It's ridiculous. Huh?
You just stepped on our project.
Can I make you a sandwich?
No.
You stop cleaning.
No.
You stop.
No.
What?
Why? Okay.
It's been a
Part
minute.
C. Okay. Part C of this problem says to determine the speed of the ball. And 3 things you're going to need to know in this part is centripetal force, which says that mass times the velocity squared is over r is equal to centripetal force, mv squared over r. R is the radius in this case, and the radius is the radius of the circle in which the ball goes around its vertical, and that's going to be equal to L sine theta. And m of the ball, which we found out in part B, which is equal to t cosine theta over g. And when we drew out our
And toast it.
free body diagram, we saw that mg and the vertical component of y are equal to each other, therefore they cancel out, and leaving only tx, the force that moves this ball around in the circle. So Tx will be equal to the centripetal force, which is mv squared over r. And we're just going to plug in r and m, so it's going to be equal to t cosine theta over g L sine theta v squared, which is equal to Tx. Now, we can't just leave Tx as Tx, we have to find it in terms of t. So, Tx is equal to t sine theta. And now we have t sine theta equal to, we're just going to skip a few steps and do some algebra on this. You're going to bring this, bring this over to this side of the equation. We're going to set this equal to b squared over here. GL sine theta all over. You're going to bring t cosine theta down here. T cosine theta. Alright, and you can just cancel out the t's here. And v is going to ultimately equal the square root of LG sine squared theta. Actually, I'm going to write it out twice. You'll see why later. Sine theta times sine theta. All over cosine theta. Now, if you notice, sine theta over cosine theta, if you remember from your trig identities, sine theta over cosine theta is equal to tangent theta. So that's going to make our life easier by making this equal to LG sine theta tangent theta. And that is the velocity.
Alright.